Hi, it's me again. So I'm going to show you this video of the sun, of my analysis of the second photograph of the sun's corona that I analyzed. And it happens to be one that I analyzed a while back in my first comparison of the sun's equatorial vortices to show that in a series of Jupiterian photographs, solar photographs, and my mapping of the Earth's vortices, how these similarities come together to identify that differential rotating celestial bodies is not just a theory, but a fact. Okay, now, I didn't really go into a lot of detail on that one, and now that I'm back at the point of revisiting some of these things and looking at it, I decided to go into greater detail on this photograph. And I'm going to close out now because we're not going to look at that one. I just used that was the last PPT I showed you guys, and I stole the title block that we see here from that slide and put it on this one, because this one I wasn't really putting the names, NASA's names on these PPTs, and then I decided, you know what, I can't remember what the hell they were called, and I don't know if I looked at them or not, so I might want to start keeping track of the titles of these diggity-doos. So I am. So this was like the very first one, and what had caught my eye at the time that I first looked at this photograph was the apparent cooler region at the north, cooler region at the south, and then in between the the eastern and western hemispheres, there appears to be this diggity-doo. Right here you can see like a line going right down this thing. Alright, now I won't use the term that first came to my mouth because, you know, sometimes I can talk like a soldier. So, anyway, there it is, right? And then I go down here, and this is where I show you what the measurement of that line is in terms of direction, and it's at a -9 degrees. So down here I'm showing NASA how I took my already mapped vortices of the Earth, and I just decided to use this particular view. Had no real, it didn't have anything to do with the sun other than me capturing the east and western hemispheric vortices in a view where they meet at the center. And then I outlined them in my green little diggity blam here, and then I applied it over here, enlarged it to fit this photograph, and voila. And then suddenly everything starts to fall into place. Now we see why we have this slight curvature up here at the top, slight curvature at the bottom. Right here where you have the tangent of this vortex meeting the tangent of the Antarctic vortex of the sun, you have a very large prominence, and that particular prominence is in conflict because you have this vortex is rotating counterclockwise while this one is rotating, well, it's rotating counterclockwise also, and because they're both rotating the same direction, their tangents are turbulent. In the Arctic vortex of the sun, you have, like it's cold up there, right? Well, it is cooler. So you have this, it's going counterclockwise, it's going clockwise. And this one is rotating counterclockwise, and because one is rotating in the opposite direction of the other, they have a flowing tangent up here, and it's a little bit more peaceful, it looks like. And then you have this one is also rotating counterclockwise, and it's also going in the same direction, or in an opposite direction as the north polar vortex of the sun, and it has a flowing tangent, but at the same time right here it has a prominence. So you have this prominence here, which is opposite this prominence here, and now we see why these prominences are where they are. They are following the points of these tangents, And we'll notice that at the tangent in the center, we also have another anomaly, a very not bright anomaly. And at first I was just like, well, there's a lot of activity going on right there, and folks don't like each other because you got this vortex is rotating counterclockwise, and because this one is also rotating counterclockwise, they are striking each other in opposite directions on this tangent, which makes it a turbulent tangent, and boom. You know what? That's what a prominence looks like head on. This is what the prominence looks like when it's off to the side of the planet. This is what it looks like when you're looking straight at it. And yeah, I got question marks down here in the bottom because it doesn't seem to be a whole lot of woodity-doos going on down here or up here. It seems so, and it brings you to the question: why are the prominences going like tic-tac-toe, right? Why is it bam, 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 and not bam or bam? We got to figure out what the hell happened to Bam Bam. All right, and you got I outlined the spiral density puzzle zones of each of these to determine the direction of their rotation. And down here in my notes, in this photograph, forget the two prominences, because at this time I'm just like, forget those guys. This is better what I have. The real discovery lies in the bright anomaly appearing at the tangent of the west and east primary equatorial vortices. This tangent is referred to as a turbulent tangent because the vortices on each side of the tangent are rotating in the same direction. This turbulent agitation sparks the anomaly as their currents countercharge and twist the solar magnetic fields. Two equatorial vortices will rotate counterclockwise, while the other two mates of these two vortices will rotate clockwise. The northern tangents of these two equatorial vortices are flowing tangents. The southern tangents of these two vortices are turbulent tangents. Ta-da! And that is my conclusion of this particular photograph analysis for NASA. I did it for NASA. I sent it to NASA. NASA didn't ask for it. NASA doesn't talk to me. So it's not like I'm out there saying that they're paying attention. Who knows what they're thinking? Maybe it's all secretive like UFOs. Don't tell anybody. Nobody saw what they saw. You did not see these UFOs. You did not see you did not see the sun. Even though we're throwing out photographs of the sun every freaking day, and we're asking people, hey, come back and tell us what you think. Well, I told you what I think. What do you think? Oh, that's right. Oh, hold on. I'm going to go talk to my rock for a moment. Oh, there it is. Hi, Rocky. Well, anyway. Oh, by the way, my middle name is it's also the nickname. My middle name's nickname is Rocky. So basically, if I'm talking to Rocky, I'm talking to myself. Yeah, go figure, right? All right, that concludes my presentation. Please like and subscribe. And I'm gonna go find some wolves over here. There we go, and kill the recording. I don't know how to do this without having to go to this screen. Like anybody wants to see this never-ending menagerie of windows. It's like, ooh, kind of looks like one of those time traveling things, like in that show where they jump into that spiraling time traveling wiggity digit. All right, well, see you later.